All right, so we are on section 4.2, and we're going to talk about synthetic division and long division today. All right, but first we're going to do a little review of what it really means to divide. So let's go back to basics. We are going to do 7 into 95. So 95 divided by 7. Another way to write that would be this. A more familiar way to write it would be that. So that's all we're doing. So if you think back to, fifth grade, whatever it was, we say, okay, how many times does 7 go into 9? 7 goes into 9 once, and then we multiply. 7 times 1 is 7, and we subtract. 9 minus 7 is 2. 5 comes down, and we do it again. 7 goes into 25 3 times. 7 times 3 is 21. And we are out of numbers to bring down. So we're done. So our answer, 7 goes into 95, 13 and 4/7 times. So 13 remainder 4. So it's the quotient plus the remainder over the divisor. So 13 and 4/7. 13 plus 4/7. So that basically tells us we are 4 units away from 7 going in perfectly to 95. So now let's try it again. Let's do 7 into 98. 7 goes into 9 once. Bring the 8 down. 7 goes into 28 4 times. So now we're talking. All right, actually, let me back this up. We're not 4 units away. We're kind of 4 past where a perfect divisor would have been. We're 3 away from it fitting into that 7 perfectly. So that's why 98 works. 7 times 28 is 28. We subtract, and we're left with 0 for a remainder. So that's a super key idea for this lesson. We're going to talk about this a lot next class. When the remainder is 0, we know this. It means that 7 fits into 98 perfectly. It fits in evenly with nothing left over. So keep that in mind. We're going to use that skill right now. So we're going to start on the left-hand side. We're going to look at polynomial long division, and we're going to see how it compares to synthetic division. So this is something you guys did last year. Again, it just always depends on how much you brought with you. So if you feel like you can try this on your own, you certainly can pause me and work on your own, and then unpause when you're ready to look it over, to see your answer, to see your work. But we do the same thing. So we want to say, okay, x minus 6 into x squared minus 4x minus 12. Another way to look at this is this. Sorry, wrong way. Is this. X squared minus 4x minus 12 divided by x minus 6. So hold that thought for a second. Let's do it the long way. So what we do is we only divide the leading term. So we just say, how many times do we have to multiply x to get it to be an x squared? We have to multiply it exactly 1x times. And now we multiply. Sometimes having parentheses out there helps people. So we multiply. X times x is x squared. Negative 6 times x is negative 6x. And we are subtracting this whole thing. If you did it right, these first two terms should always subtract out to a 0. So we have 0 here. You definitely don't have to write that. Negative 4x minus a negative 6x is a plus 2x. And now we bring down the 12. So we have the next line is 2x minus 12. All right, we do it again. How many times does x go into 2x? How many times do we need to multiply? We need to multiply it exactly 2 times. So plus 2. And we multiply. X minus 6. X times 2 is 2x. Negative 6 times 2 is negative 12. Remember, we're subtracting. 2x minus 2x is 0. 12 minus negative 12 is 0. So we have 0 remainder. So that tells me x minus 6 is a factor of x squared minus 4x minus 12. In fact, it goes into that term x plus 2 times. So that makes perfect sense, because x minus 6 times x plus 2 does give us this x squared minus 4x minus 12 polynomial. All right, so x squared minus 4x minus 12 divided by x minus 6 leaves us this. With 0 remainder, that means it's a perfect factor. So now going back to this is something we could have done a much easier way by factoring. So this is kind of another way to check our work. I just did that wrong, didn't I? That should be a plus 6 minus 2. Plus 6 minus 2, sorry about that. Well, you guys got the idea. So it factors out and divides out perfectly. So this divided by this is this. And that's exactly what our long division told us. So let's match that up. Let's compare that to how synthetic division works. It's very similar. So we're only going to look at basically the coefficients. We're only going to look at the number in front of everything. And that's all we really need. So to set this up, and you may have learned this a different way last year, just how it's set up. This is how I always did it. So x minus 6. All we're looking at is that constant, the 6 there. The coefficient of x squared is 1. The coefficient of the x term is 4. The coefficient of the constant is negative 12. And we bring this down. So we bring that 1 down like this. And it's very similar to what we did right next to it. So as you're going, you can kind of look back and forth, compare the synthetic to the long division. 6 times 1, we bring that 6 up. And now we subtract, just like we did here. So now we're basically on this step of my long division. Negative 4 plus 6 is 2. 6 plus 2 is 6 times 2 is 12. 12 minus 12, or negative 12 plus 12 is 0. So there we go. Again, 0 for a remainder. And if you look closely, and if you remember back to last year, those numbers that we have left over, those are the coefficients of our quotient. So we have 1x plus 2. So again, we have quotient, which is here, plus the remainder, which is here, over the divisor, which is here. So maybe we should make a note of that. Quotient, remainder, divisor. So there you go. Let's try these next two. So I'm going to pause and work through this on my own. You guys can do the same thing. If you were totally stuck, obviously just unpause right away and I'll be going through it with you step by step. But see if you can get this on your own. See if you jog your memory from last year. So go ahead and pause now if you haven't. All right, so let's see how we did. To multiply x to get to x squared, we need to multiply that exactly 6x times. So that's where I got this from. We multiplied x times 6x, negative 4 times 6x. That's how I got this line. And we subtracted. Negative 26x minus a negative 24x is a negative 2x. We bring the 12 down. And then x goes into negative 2x, negative 2 times negative 2. So we do it again. We multiply x times negative 2, negative 4 times negative 2. We subtract, and that's how we get our remainder of 4. So this x minus 4 does not go in evenly to 6x squared minus 26x plus 12. We have our quotient, which is right here. We have our remainder, we have our divisor. Quotient plus remainder over divisor. So that does not go in evenly. We'll talk about that a lot next class. So our synthetic division, hopefully you had this set up. I bring my 6 down, pause if you need to. 4 times 6 is 24, adds to a negative 2. 4 times negative 2 is negative 8. There's your remainder. So you can see how much quicker the synthetic division really is. All right, so we're going to practice this a lot next class. Note if there's no remainder, what I've been saying above, if there's no remainder, then the divisor is a factor of the polynomial. It means it goes in evenly. So synthetic division, it's a shortcut for long division. You can see how much quicker it is. It's very helpful when the degree is a third degree polynomial or higher. And this is the big one. The divisor must be linear, and it must have a leading coefficient of 1. So I'll show you a quick example of that in a second. Must have a leading coefficient of 1. So when you are ready, you can flip to the next page, pause if you need to. Let's see how we're doing. I want you to try this one on your own. So I'll probably pause again before you just jump into it. So I want you to divide using synthetic division. I want you to divide 3x to the fifth, et cetera, et cetera. I want you to divide it by x plus 2. And I don't know if I mentioned this in the first page, but if x plus 2 is what we're looking for as the factor, if that's what we're dividing, we're testing -2 with our synthetic division. That's the number we're putting on the outside. I guess I didn't really mention that. If x minus 6 is what we're dividing, x equals 6. Basically, we're checking if 6 is a root. All right, so I hope that makes sense. So if x plus 2 is the factor, that would mean x equals -2 would be the root or the 0 of that. So that's what we're testing with the synthetic division. What you need to be on the lookout for is this missing x squared term. So I actually wrote that below already. All right, there's no x squared term, so we can't just skip it in our setup. We have to put that placeholder 0 there for you. All right, so I want you to try this one, and I want you to try the third example, the 4x to the third minus x minus 10. So try those two out. I'm going to do them while we're paused, and then we'll get back together and we'll finish up the video. So go ahead and try those two now. All right, so how'd you do? Make little notes to yourself if there's little things you're having trouble with. We'll talk about it in class, obviously. So right here, these coefficients, here's kind of an interesting thing that happens. When we think about what we're actually doing here, we're taking this 5th degree polynomial and we're peeling a layer off of it. We're kind of peeling this x plus 2 layer off of the onion. So after we do this synthetic division process, it makes sense that we go from a 5th degree function down to a 4th degree function. So that should always happen. So when I look at my coefficients, 3x to the 4th minus 1x to the 3rd minus 2x squared plus 4x to the 1st minus 1 plus the remainder over the divisor. And the big thing here is no, it is not a factor because the remainder does not equal 0. It's like 7 does not go into 95 evenly because there's a remainder left over. X plus 2 does not go into this polynomial evenly because there's a remainder left over. All right, I didn't do that one. We'll have plenty of time to try these out in class. But the other thing I wanted you to take a look at, this 2x minus 3, remember what I said on the first page. We have to have a leading coefficient of 1 here. So we can't do synthetic division as it's written like this. We have to change it to become x minus 3 halves. So that's where I get my leading coefficient of 1. So what we're actually testing here, since this factor is x minus 3 halves, we're testing positive 3 halves in my synthetic division. So again, notice my placeholder. There's 0x squareds again, so I have to put that in my setup. I crunch my numbers, careful with that fraction. And again, we have no, this is not a factor because the remainder does not equal 0. So I have my quotient plus the remainder over the divisor. All right, what I want you guys to think about for homework, try this next question out. So, well, you know what? These are a ton of just examples. We're gonna try a few more in class, make sure we got the hang of it. But I want you to jump down here, and I want you to see what happens. So I want you to do synthetic division here. So synthetic division to do this division actual process. And then I just actually want you to do what is p of -1. So evaluate that same function for p of -1. So see what happens. Think about what that tells us, and how that might help us going forwards. All right. So I hope that makes sense. I will see you guys in class. Yeah. Talk to you soon. Bye.